Hi everybody, in this video I am going to find super key, primary key, candidate key from a table or relations. So from any table we can easily find all the keys one by one. So let us consider the example. Suppose the relation R equal to A, B, C. So R consists of three attributes A, B and C. So R is a table which consists of three attributes, that is A attribute, B column and C column, and their corresponding values. First of all, we need to find out the function dependencies. Function dependencies, FDs. What are the possible FDs? We can find out A to B, C. We can find out easily determine B to CA or AC, C to AB. A can determine BC, B can determine CA, C can determine AB. Similarly, AB can determine C, AC can determine B, BC can determine A. Now, ABC can determine ABC. So these are the possibilities of function dependencies from the above table. We can say super keys are A can be a super key. Why A is super key? Is uniquely identified. It is used to uniquely identify the record. So A can be super key, B can be a super key, C can be a super key, AB can be a super key, BC can be a super key, AC can be a super key, ABC can be a super key. So they are known as super key. So first of all, we need to find out super keys. These are super keys. Now next step is to find out the candidate key. To find candidate key. Candidate key is the one whose proper subset is not a super key. Whose proper subset is not a super key. This is the concept. Whose proper subset is not a super key. So we need to find the less number of attribute. We need to find out the less number of attribute. Here, AB cannot be a super key. It cannot be a candidate key. Why? Because A is already available. As A is a proper subset of AB. So AB cannot be a candidate key because A independently exists here. So AB cannot be a candidate key. Similarly, BC cannot be a candidate key. It is not a candidate key because independently B exists here, not a candidate key. B is available here. Similarly, AC is not a candidate key. ABC is not a candidate key. So we can say A, B, C, they are candidate key. So first of all, we need to find the super key. Then from the super key, we need to eliminate the proper subset. We need to find out the super key. Then from the super key, we need to find out those subset which is not used as key. Here, A is used as key. So AB is not a candidate key. Here B is a used as key, so BC is not a BC. Here B is used as a key, so BC is not a candidate key. Here A is used as a key, so AC is not a candidate key. So we can say A, B, C are candidate key. We need to find out the primary key. So these are super key, these are candidate key. Now we need to find out the primary key. We know that the minimum number of candidate keys is known as primary key. So here from the we can say A is a primary key. Can be a primary key. Minimum we can choose A, either A or B or C, or B is a primary key, or C is a primary key. We need to choose any one of them as a primary key, because among A, B, C we can consider either A, either B or C. So this is the concept through which we can find out the primary key. So from the above table, first of all we need to find the FDs. From the FDs, they are all uniquely determined. They are known as super key. From the super key, we need to eliminate those set that are available as a key. Here AB, from the AB, A is already available, so we need to eliminate AB. From the BC, B is already available as a key, so we need to eliminate BC. From AC, we need to eliminate A is already available. Similarly, ABC can be eliminated because here A independently exists, is not a super key, is not a candidate key. So here A, B, C are candidate key. And primary key is the minimum number of candidate keys. So we can either choose B, A, or B or C. Any one of them we need to choose from the candidate key. So this is the concept through which we can find the different keys from a table or relation. So thank you very much for watching this video. Share and subscribe it.